So state the principle of conservation of energy. Please do that while I'm drawing this diagram. A circle, smooth circular wire, radius A, same as the last question that we've done. Here it is. We have a little ring on it of mass M. M is equal to M. Threaded onto the wire and it's projected from its lowest point. The total energy at the instant of projection is mgh plus a half mv squared, which is M times G times 0. If we take this as H is equal to 0, we're told that U squared, which we need, is equal to 2GA. So that's plus a half M times 2GA. So 2's cancel. So the total energy in the system is just mGA. mGA. The greatest height reached by the ring next. So let's look at the greatest height. Well, let's just assume that it's here, this ring, and then we look at position 1 to position 2. We have position 1 is mgh, so let's look at position 2, or sorry, mga. Position 2, the greatest height, the velocity is going to be 0, so the half mv squared is equal to 0 at the greatest height. So mgh at the greatest height. We don't know what h is, so we're looking for the greatest height. So this mgh has to be equal to mga. So therefore, you can see if we divide across by mg, the greatest height reached is the radius of the circle A. In part 3, we're asked the speed, so we're looking for v when the ring is equal to half its greatest height. Well, let's just put it here for the sake of argument. So the greatest height is A, so half A is half the greatest height. So we still have position 1 as mga. Position 3 now we'll call it, I suppose. Position 3 is mgh, and h is half of A, so A and the whole thing over 2, or a half A if you want, plus a half m. Now we're looking for the speed, v squared. This is all going to be equal to mga. So we divide by m. You can see that we have GA on the right and a half of GA on the left. So we're just going to bring the half GA across to have GA over 2 on the right, but I'll write it on the left. And that's equal to V squared over 2. So you can cancel your 2's and say that V squared is equal to GA. So V is equal to the square root of GA, and that's in meters per second. Number 10 now. Johnny, whose mass is M, sits at one end of a light seesaw at ground level. Here's Johnny. Ground level. He has mass M. Marjorie, whose mass is 3m over 2, sits at the other end. So I'll write 3m over 2 for Marjorie. And it's half a meter off the ground, so this is 0.5 m. Find her common speed when she's, boom, just about to hit the ground. Okay, well, let's look at mgh plus a half mv squared here for position 1. So it's on the ground, so it's m by g by 0 plus a half. We don't know the speed, m by v squared. So the total energy of the system is mv squared over 2. At position 2 here, we have mgh plus a half mv squared again. And actually the speed here for this guy is 0, isn't it? So we have 0 here. M over 2 times 0, which is equal to 0. So the total energy in the system is both of them added together here. So just be careful. So mg by 0.5 plus this one is 0 as well, a half m by 0 squared. So we have 0.5 mg as the energy in the system. And just be careful with your m again. This m here is 3. I'll write 1 over 2 for 0.5, and this m is 3 over 2m. So just getting Marjorie's m correct. So that's going to be 3 mg over 4 as the total energy in the system before. the energy in the system after. Position 1, m g by 0.5 plus a half m by v squared plus the two energies down here, which is 3m over 2 by g by 0 plus a half 3m over 2 by v squared. So tidying this up, we're going to get a half mv squared plus 0.5 mg from position 1, and then from position 2 we're going to get 3 mv squared over 4 for this one. And then letting these equal to each other. Before it was 3 mg over 4, afterwards is these 3, so 1 over 2 mv squared plus 3 mv squared over 4, bringing the v squareds together, plus, I'll write this as 1 over 2 mg, dividing by m, and I have 3/4 of a g on the left, and I'm bringing a half over to it, so 3/4 minus a half, this 3/4 g minus a half g is just going to give me a quarter g, or just g over 4, a quarter g. That has to be equal to a half v squared over 2, so half of v squared plus 3/4 of v squared, and that's 1.25, that's 5v squared over 4. So multiplying by 4, we're going to get 5v squared is equal to g. So v squared is equal to g over 5. So v is equal to the square root of g over 5 meters per second.